Okay, now we want to talk about small stars and what happens to them. So notice that the mass of these objects are going to be between 8% the mass of the sun up to 0.4 times the mass of our sun. So our sun, which is on this scale, is going to have a mass of 1, is not a small star. So we're not talking about our sun here. We're talking about objects that are going to be smaller than our star, but they're going to be bigger than Jupiter. So if you recall, Jupiter had a mass that was less than 8% the mass of the sun. So these are going to be objects that are between 8% the mass of the sun up to 40% the mass of our sun. Now these do have enough mass to cause enough force, to cause enough pressure, to cause enough temperature to get to that magic number of 10 million Kelvin. So these objects will ignite, and when they ignite, they will start to convert hydrogen into helium. We're going to call these things a red dwarf because they're going to be relatively cool. So if you recall, we said that the mass of a star determines the core temperature of the star. So these objects are going to have a core temperature that reaches 10 million Kelvin, but that's pretty much it. And so the surface temperature of these kinds of stars is going to be very, very low. And so notice that their color is red. So if we go back to the HR diagram, and the HR diagram had the brightness of the star over here, so that was its luminosity, and then over here going sideways was the temperature, and then down here in the corner was going to be stars that were the color red. So that's going to be the red dwarfs. Now if you want to actually plot, in addition, if you wanted to plot these brown dwarf things, then they would be way, way over here somewhere. So their temperature would even be less than the red dwarf. So on your HR diagram, this is the main sequence right here. We're talking about objects that are in this corner of the HR diagram. So these things are going to have a diameter of between 4 times the diameter of Jupiter up to 0.4 times the diameter of the sun, and they're going to have a density between that of Jupiter and the density of the sun. Now eventually though, these things are going to start running out of hydrogen. So currently a red dwarf is taking hydrogen and smashing it and turning it into helium, but eventually it's going to start to run out of hydrogen. So that means that those nuclear explosions, which were keeping gravity at bay, so the nuclear explosions are making the thermal gas pressure that was keeping gravity from crushing this object and turning it into a black hole. So as soon as it starts to run out of hydrogen, that's going to be really bad, because that means the nuclear explosions, they die down, gravity's going to take over, and it's going to start to cause this thing to collapse. So as it collapses, its temperature is going to go up. So the ideal gas law. As it's collapsing, the pressure is going to increase and the core temperature is going to increase, but it's not going to get to a magic number of 100 million Kelvin. Now you don't need to know that number for the exam, but 100 million Kelvin is going to be the next temperature needed in order to turn helium into the next element over here, which we'll talk about in our next segment. So these objects, they just don't have enough mass to generate enough gravity, to generate enough pressure, to generate enough temperature to get to that 100 million Kelvin thing. And so they are eventually just going to cool off into a substance that is going to consist of a lot of helium, And again, it's going to take probably hundreds of billions of years for this to happen. So notice that it will happen faster than what the brown dwarfs turned into black dwarfs, but still it's going to take hundreds of billions of years for this to happen. But eventually it's going to turn into a black dwarf, and its gravity is going to be countered by electron degeneracy pressure. Gee, that sounds like just what happened to the brown dwarf. And it is. So the brown dwarf turns into a black dwarf, and so does the red dwarf. So they have exactly the same endings to them. All right, so let's take a break, and when we come back, we're going to talk about medium-sized stars.